Today we are going to see about statically and dynamically induced EMF. Here figure shows the three conductor A, B, C moving in a magnetic field of flux density B in the direction indicated by arrow. Conductor A is moving in a direction perpendicular to its length and perpendicular to its flux lines. Therefore, it cuts the lines of force and motional EMFs induced in it. Let the conductor move by the distance dx in time dt if the length of conductor is L and area swept by conductor L into ds. Therefore, the one conductor D equal to BL into ds. E equal to ds by dt is equal to Bs into ds by dt, where ds by dt equal to V. Therefore, E equal to BLB volts, where E is the EMF induced, B is the flux density in Tesla, V is the velocity of conductor, L is the length of the conductor. The motion of the conductor B is at an angle of theta to the direction of field if the conductor moves by a distance dx and the components of distance travelled at right angle to the field is and proceeding above the induced EMF is F equal to E equal to BLB sin theta. The force F particle of charge Q moving with the velocity V in the magnetic field B, F equal to Q into V into B. Dividing F by Q, we get the force per unit charge. So E equal to F by Q equal to V by V into B. So dividing F force by E equal to close interval of E into dl equal to close interval of V into B into dl. Statically induced EMF or transformer EMF. The statically induced EMF is induced by variation of flux. It may be mutually induced or self-induced EMF. A mutually induced EMF set of coil whenever the flux produced by neighboring coil changes. However, a single coil carries alternating current. The flux will flow through change in the current. The total flux linking lambda of coil is equal to the integral of normal component of flux density B of the bounded of coil. So the surface over the integration is carried out to the surface bounded by the periphery of coil, lambda equal to double integral B into ds. So E into d lambda by dt equal to d by dt double integral of B into ds. So E equal to d by dt of double integral of B into ds. When the coil is stationary or fixed, therefore E equal to integral of dou B by dou t. So where E is equal to EMF induced, B equal to flux density, d is the element of area in meter square, t is the time in